Hello, dear students. A very good luck to all the board examinee. We are starting this video for a complete revision. As you have seen the name, it is real number in one shot. This is precisely for the quick and comprehensive revision of your board exam, for your board exams 2025. We'll try to take all the chapters with all important problems, with all important concepts. So that will help you. Obviously, as we are taking the entire chapter, time taking will be little more. So don't get bored. Continue with the video. Don't leave it in between. You can take a pause and then you can take rest little, 5 minutes break, and then you can still continue. So it will be a big and long video, right? Don't leave in between. I promise you that I'm going to revise all the concepts and all type of problems which are basically set in board exam. So let's start with. So we are going to start with our concepts. First, let us see this real number is containing what in your class 10 syllabus. It's not a big chapter now. Many parts are deleted. So we are having now these two things, three things: fundamental theorem of arithmetic, HCF and LCM, and irrational numbers. These are the three things which we have to study, and all problems will be under or within this only. Now let us move further for a quick recap of what exactly is needed as a theory part. The first thing is the fundamental theorem of arithmetic. Fundamental theorem of arithmetic. It is a very important part. So you need to know the statement also. There may be options that they will ask for you writing the statement, maybe in case study problems or 2 marks problems. What is given? Every natural number can be expressed as the product of its prime factors, and this representation is unique. I'll explain you what is unique. So far, the order of the occurrence of the prime numbers or prime factors are not considered. I could have changed the statement also. So far, the order of occurrence of the prime factors are not considered or not are concerned. That could have been a better statement as well. No problem. So what does it mean? I'll take a small example and then I'll explain you quickly. So please see this, what exactly they are trying to tell you. Suppose you take a number 30 and I ask you that you do the prime factorization of this. So you start dividing by 2, you will get 15, you will be getting 3, and then this is 5. So what did you get? 30 equals? You get 30 equals 2 into 3 into 5. Supposing that another student wants to do the same thing, but that particular student tries to divide this by 3 first because he has seen 30 is divisible by 3. No problem, no issue. And then suppose by 2 and then 5. And he has written that this is 3 into 2 into 5. Do you find that they are, or maybe the second student is wrong? Not certainly. It's also correct. So that's what the uniqueness is. That means if the prime factors are correct in numbers, they're coming correctly. Wherever you are writing that prime factors, that order is not a matter. So that is the fundamental theorem of arithmetic. So very, very important. Please read this statement and keep it in mind so that if they will ask, means in exam statement will be asked, you can write it down. Fine. Now next important concept is about the HCF and LCM. We already got it. HCF and LCM, we got it in our lower classes. If you remember, 5 or maybe 6 we have started with. And actually we understood or we use this method only, factorization method only to find what is the HCF and LCM of two numbers or maybe more numbers, right? But we have another method, Euclid's method is there, but that is not there in the syllabus now. Okay, what is there? HCF stands for highest common factor, right? That means if you take two numbers or maybe more, you find the common factors of all those numbers and you identify the highest. That is HCF. Quickly, I'll explain you so that it will be convenient for you. To explain you, I'll take small numbers so that it can be done quickly. I take two numbers, say 4 and 6. What are the factors of 4? Right from 1. Here it is not necessary that you will consider only prime factors. You take all possible factors. 1, 2, and 4. These are the factors of 4. What is the 4? What are the factors of 6? It is 1, 2, 3, and 6. Now let me try to identify the common factors. So common factors are 1 and 2. What is the highest of them? 2. So HCF of 4 and 6 will be 2. So these are very small numbers, so we could easily do by uh, this trial, right? Finding the factors and then identifying the highest of them. But whenever these numbers will be bigger, we will not be able to do so because it will take a lot of time. So for that, we will be using prime factorization. Then LCM stands for lowest, or I can say least also, common multiple. So the reverse is there. Earlier, in case of HCF, we have found the mm, factors, all possible factors of the given numbers. On the other side, for LCM, we'll find the multiples, right? Multiples. So I take the same numbers and let us try to find what are the multiples of 4. So 4 ones, you take positive multiples. This is important. 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 4 six are 24. I'm writing up to this only. And then 6 also you take. 6 ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24, and so on. Now, lowest of the common multiples. So, what are the common multiples of 6 and 4? We have found it. The first common multiple is 12. Second common multiple you can find is 24. Now, if you go with this list, you will find third will be 36 like this. Now, what is the lowest of this? 12. So 12 is the LCM of these numbers 4 and 6. So the same can be done for a bigger sort of numbers also. But remember, it will not be as convenient as this because these are small numbers. Fine. We can also use, this is a very important thing, we can use GCD for HCF. GCD means greatest common divisor, right? Greatest common divisor. So you keep this name in your mind. It will be better if you have this alternative name. Next, for HCF and LCM, actually, uh, the basic process which we actually have formulated. We means this after doing the factorization, how we can make it short to identify immediately the HCF and LCM. So this is the two definitions. Also, you can say not definitions exactly. These are the tools by which we can find the HCF immediately by prime factorization. HCF is the product of the lowest powers of the common prime factors. Suppose now I again go for those 4 and 6 only, so you can easily correlate. First, let us understand the statement. Product of the lowest powers. Lowest powers of what? Common prime factors. So let me now this time identify the prime factors of 4. Remember it, this time factorization should be done with the help of prime factors. So only one prime factor is there, that is 2. So 2 into 2 is 4. So I'll write this as 2 square. 6, I have two prime factors, 2 and 3. Both the powers are 1 here. So now if I want to find the HCF of 4 and 6, how should I proceed? Yeah, you find first the common primes. So out of this common prime factor is 2. So I put 2. If more will be there, I'll put that. For bigger numbers, you'll be getting more. Then you have to identify the lowest powers. So you try to see in the first number, the power of prime factor 2 is 2, and the second number, the power of 2 is 1. The prime factor 2 is 1. Which one is the lowest? 1. So 2 to the power 1, that is giving you the HCF. And just the reverse of this is the LCM. But remember, for LCM, I need all the prime factors. It's not that only common prime factors. That is very important difference to be observed. So with the same notation, I can find LCM of 4 and 6 will be, I have to write all the factors. So 2 is a factor, 3 is a factor I have written, and now I have to find the highest power. So 2 square is there and 2 to the power 1. What is the highest? Square. Okay, very clearly 3 is not there in the upper number, that is 4. So obviously 3 to the power 1, that will be the highest. So now this is 4 into 3. I mean, yeah, 4 into 3, that is giving you 24. So this is what exactly we got in our previous observation as well. So this is the process by which we can find, by using prime factorization, the different, for different numbers, HCF and LCM. It can be extended for more than two numbers as well. We'll be getting examples. Okay, in between, in meantime, I say that as you're already you're clear about the concepts, I'm moving a little faster. So this will help you finishing course or finishing revision quickly. Okay. So just let me change the ink color. Yes. Hmm. An important result on HCF and LCM. This is, believe me, this is very, very important result. And we can definitely get some problems. And I am expecting this year also you'll be getting a problem on that. For any two positive integers, remember it, this word is very important. This result is only for two, not for any others. So for any two positive integers A and B, product of the numbers is equal to product of HCF and LCM. Product of HCF and LCM. Very, very important. And it is to be noted, I have already noted also that this result is true only for two integers, not for more than that. So I'll be using it, so I'll not take an example. But in the meantime, I'm remembering one very, very important observation. So that observation is very, very important. Please try to make it a point to remember. I want to go back to the previous slide. The reason is very clear. It will be derived from this only. So you see the definitions, right? In case of HCF, you are taking only the common prime factors and the lowest powers of their occurrence. While in LCM, you are taking all the factors, all the prime factors, and the highest powers. So don't you feel that whatever factors I have taken in LCM, that will all include the factors taken for HCF? I mean to say that factor occurring to find the HCF are already, or they will definitely be the factor of LCM. It means HCF is always dividing LCM, no matter how many numbers you take. So this is a very important conclusion which was missed out in the slide. I'm writing it. HCF always divides LCM for any given number of numbers. Right? This is a very, very important observation. This can make many problems very, very comfortable. I can say you right now only, let me tell you one thing. You may be getting a question because I haven't seen this kind of questions in the last year's paper. If I say that I have two numbers A and B, right? I have two numbers A and B, and HCF is suppose 24 and LCM is 30. Can it be possible? Right? So just random observations might say, okay, possible क्यों नहीं हो सकता? It can be, but it is not possible actually. Why? Because whatever factors are coming here, that should be necessarily the factors of LCM. But you can see 24 doesn't divide 30. So this is not possible. So this kind of questions can be there maybe for your MCQs, or maybe for 2 marks, or maybe sometimes for case studies. So please be alert about that. Okay. Now, the last part of our theory is irrational numbers. Irrational numbers we had been studying from right from class 9. We have in-depth idea about the irrational numbers. Irrational numbers are what? Those numbers which you cannot express in the form of p by q, roughly saying in the form of fractions where numerator and denominator are integers. If you fail to do so, those numbers are said to be irrational numbers. So the definitions I'm not giving you, but just I want to include that there is an important theorem in this particular topic, because while proving by the method of contradiction some numbers to be irrational, we need to have this theorem. This is a very, very important theorem, right? Very, very important theorem, and we have to state it. So I have written the symbolization as well. You can use this, right? So what is the statement here? If a prime number p divides a square. Okay, let me make it one more clear thing. Things very clear that as we are here in the number theory part, these numbers are automatically integers. If I say numbers, you should understand that we are talking about integers, not any other. So if you're talking about a prime number which divides a square, that is square of some numbers, then it is very much necessary that p divides a as well. It has to divide the number a also. By symbol or with the help of symbol, how we write? P divides a square. This slash is for division. Actually, I use the italic so it becomes little inclined. It should be very straight. Your proper thing is, yes, P divides a square implies P divides a, not a square. This is P divides a. So that is by that side you must write P being a prime. See, these are very, very small uh, tail part, which is very, very meaningful. So don't leave it. Because of this, also sometimes we may ask questions. And also there is an exception. It is noted. It is to be noted that if P is not a prime, the result is not always true. Sometimes it may be true, but not in general, right? So I just want to give one example to you so that you can identify. I want to give the example for the um, contradiction, means which is not true. I'm not giving the example for that which is true. If P is not a prime, what may happen? That I want to show you. You consider P a prime. You have to consider. Sorry, you have to consider a number which is not a prime. Say I'm considering 4, right? 4, and the number A I want to consider as 2, right? Or maybe okay. Let me consider a little bigger number, 6. So you can easily see A square is 36 and 4 divides 36, right? But 4 is not dividing 6. And this mishap occurs because I have started with a number which is not a prime, right? This result will always be true if it is a prime. And these things comes actually from the prime factorizations of integers with the help of fundamental theorem of arithmetic. So this is a very important theorem. Okay, let me now go for the questions. Dear students, I would like to again tell you that after discussing the theory part, I think you can refresh your ideas. Now let's start with the questions. Basically, I have taken the questions of the last year's 2024. And when I collected, I thought that it will be less in numbers, but there are many questions. So I have just taken 2024 question paper. And you'll be like surprised to know that all regions of CBSE, they have covered all type of problems in various regions differently. So whatever I am going to do, it will be exhaustive. So just try to keep in mind what type of problems you are going to face in the board exams. So let us start. What is there here? What is the first question? It is MCQ type. I'm trying to take the questions which are of different types so that you will always feel privileged to attend this particular class. Okay, I'll take a arrogant color here, red color. Okay, your first question. I'll go first, sir. Two positive integers p and q can be expressed as p is equal to, I'll keep on writing also, 18 into, just a minute, this is to be removed. Yes, 18 into a square plus b to the power, sorry, a square into b to the power 4, and the q is equal to 20 a cube b square, where a and b are prime numbers. I know that. Now LCM they are asking. So LCM means you have to take all the factors and you have to take the highest power, right? So one thing is very sure, that a and a cube. So for LCM, I get a cube, no doubt about that. I get b to the power 4. After doing this much also, you foresee, is there any option which is having only this, right? Then your task will be easier and shorter. So here you can see it is not, it is not, it is not. So you're lucky you need not do the numerical part. So that is a clever way of answering it. So your option is this. Right? So MCQ do not always try to do it exhaustively. See first which particular options you can discard. If you have three options which you can discard immediately, so fourth option is the answer. So we have got the answer D. Okay. So now next, yes, HCF of HCF of 2520 and 6600 is 40, while the LCM is this much. What is the value of key? So we have already discussed the various very important result for HCF and LCM of two numbers. What was that? Product of the number is equal to the HCF into LCM. So 2520 into 6. Acha, these are multiple choice questions, so I'm not writing any statement. I'm working out only these things. This is equal to what? Product of the HCF. What is the HCF? 40. What is the LCM? 252 into K. Okay, now here let me try to tell you, dear students, there are many students who commit a big mistake. I say big mistake. Why? Because they try to multiply all these and then they try to divide this. Don't do this. This is a foolishness. It will take a lot of unnecessary time. Don't do any multiplication, right? So simply what you'll do, it is K here. So it is 2520 6600 divided by 40 to 52. Right? Do this. Now you see this 0 and this 0 will be cut, and readily this you can cancel. Good. Now by 4 you can divide it. That also you can do by clever way. How clever way you can do it? You just write 66. Right? You write 66 as 66 into 100, because 100 you can easily divide by whom? 4. So it will not take time because you can do it orally. 25. Right? So 25 into 6, you can easily multiply. Even you can do the oral multiplication. I am not doing that. 25 into 6 is 150. So 15 will be carried. It is 25 into 6, again 150. It is 165. So that is the value of K, 1650. Right? So that is a way. Right? Okay. Achha, one more thing. In the meantime, I just want to tell you, because what I have shown you written here ultimately is wrong if I talk about the mathematical point of view. If it is a descriptive problem, don't leave the answer like 1650 equal to K. It's a wrong statement. At last, you have to correct it. Always the unknown should be in the left side. Be very, very alert. Here we don't need, because this is MCQ. Okay. Now next you come to the Say third problem. A equal to 2 to the power 2 into 3 to the power x. This is the number A. What is B equals? 2 square 3 into 5. C equals 2 square into 3 into 7. They are asking for the value of x if they have given you LCM. Okay, fine. Let us start. What is the LCM? It is 3780. And what is the LCM which we can find by using that formula? It is all the factors, right? So you can see, read all the factors are what? 2 is a factor, 3 is a factor, 5 is a factor, and even 7 is a factor. And you have to identify the highest power. So 2, all the powers are 2. So it is 2 only. 3, it is 1, right? So for a moment, because they are asking you to find x, because they are asking you to find x, for a moment, let me give the benefit to that, considering 3x to be bigger than 1. For a moment, let us see whether it is possible or not. And then 5 power is 1 and 7 is 1. Now, obviously, here if I need to find x, I have to do the division, right? Here also I'll try to do it little cleverly, right? So 3 to the power x is equal to 3780. Let me not factorize it immediately. I can see something. 2 square is there and this is 5. So one of the two I'll take and 5 I'll take and I'll make it 10. 2 is there and 7 is there. So now this 10 will cancel it. So my calculation becomes substantially easier. Now this will cut it by 1. 16 if it is. 8 to the 16, 189. 189. Then again you divide. Uh, 7 will divide it by 2. And this is 7. That's great. 3 to the power x is equal to 27. That is equal to 3 cube. So what is the value of x? 3. So your answer is 3. Right? Your answer is 3. So that way you can see it. Or you can do one more thing. You can directly factorize this and you can cancel these factors. That's all. You can get many other ways as well. Okay. Now you come to the next question. What is the next? A pair of irrational number whose product is a rational number. Right? You have to identify. This time the pairs are given, so you can directly write the pairs. You all know that it's not a difficult problem. Class 9 only you can think about. So here I'm writing it. A is equal to what? What will be the value here inside this? 16 into 4, 64. So it is giving you 8. So it is not the case. Ruled out. This is irrational, right? Because root over 10. Product. Sorry. I read it in the reverse direction. Rational number, which is rational number? Yeah, which I discarded is the rational number. Rest all are irrational, right? Because this will be 81, so 9 will be the square root. 36 into 2, 27 into 3. A pair of number whose product is a rational number. 16 fours are. No. 16 fours are 64. 6 fours are 24. 64, sorry. 64 is a rational number. Then 3 into 27. Is this question wrong? Because 3 into 27 is 81. Right? 81 square root is 9. 16 into 4, it is 64. It is square root. So 8 is your 64. Then this is root over 10. And then this is root over 72. So there is a mistake in the problem because there are two numbers, right? Find a pair of irrational numbers. Oh, yes. Yes, see, it was deceptive. I was doing in hurried manner. This will not be the option. Why? Because they are saying one thing that has been omitted. They are saying irrational numbers, right? So these are not irrational; they are rational numbers. So product of rational is obviously rational. So these are the two irrational numbers whose product is a rational number. So you see, in hurried manner, you might mark A also. Be very alert about that. Okay. Now next, what is the next? The smallest rational number by which you will multiply root over 20 so as to get a rational number. So first you see, if you factorize root 20, what are the factors coming? It is 2 square into 5 to the power 1. So if you want to make it as a perfect square, you already know even from class 8, all prime factors should come in pairs. So what is not here which is coming in pair? 5. So only one 5 if you multiply, it will become what? This particular number will become a perfect square. But they are not asking this question. By which you will multiply 20. They are asking you by which you will multiply root over 20. So root over 20 is basically 2 root 5. And you are multiplying this number inside the root. So outside what it will be? Root over 5. So this is the number by which you will multiply root over 20 so that you can get a rational number. So your answer is root over 5. Right? See, to make it deceptive, to make it confusing, they have given you this option also. So there may be a good chance that you can opt for this. Be very alert about that. MCQs are in that way really tough questions. Okay. HCF of two number is 65. HCF of two numbers 65 and 104 is 13. LCM is 65 of LCM of 65 and 104 is 40x. You need to find the value of x. So very good. We use that same thing. See, I was telling you that theorem is very important. That product of two number is equal to product of two positive integer is equal to HCF into LCM. They are repeatedly used. We got many things, many questions of different types in the same year. So 65 into 104. This is the numbers. And what is the HCF? It is 13. What is the LCM? 40 into x. Now I need to find the x. Very simple thing. You can do it orally. 13 will come down here. So 13 fives are 65. You got this, right? And then 40 will it divide 104? Is it 40x? Yes, it will divide. How it will divide? Right? So you can cancel also. By 2 if you divide or by 4 you divide, then you'll be getting 10. By 4 if you divide, it will be 26. Then by 5 it will be 2 times. This 2 will cut it by 13. So what is the value of x? You have the value of x as 13. Easily you can do it, right? Okay. Yes, that is a good question on prime factorization. If you have this, what is the value of that? So for this, you definitely have to know what is x, y, and z. So you are indirectly told to do the factorization. So you start doing this, right? So is this divisible by 3? Let us start. Or see, prime factor, fundamental theorem of arithmetic has given you freedom. You can start with any prime factors. There is no problem. So why to waste time to check whether it is divisible by 3 or not? 5 it is divisible, I can see. Let us do it. So 5 7 are 35, 32, 5 6 are 30, and then 5. Again 5 will divide it. It is 1, 5 and 3. Now 153. Yes, now you can easily check. 153 is divisible by 3. Why? Because 1 plus 5, 6, 6 plus 3 is 9. So this is 5, 1. 51. Is it divisible by any number? Is it a prime? No. By 3 again it will be divisible. 17 will come. So now if you write this entire number in terms of this exponential expression of the prime factor, so I can write 3 to the power, sorry, it should be, anyway, let me write that given one. 3 to the power x into 5 to the power y into 7 to the power z, which I got as, how many factors I got? Two factors. So 3 square, 5 square, and 17 to the power 1. Now compare, what is x? X is 2. What is y? Y is also 2. What is z? Z is 1. So x plus y is 4, minus 2z is 2. So value is 2. So which part? C is the answer, right? So C is the correct answer. Good one. Okay. The greatest number which divides 281 and 1249, leaving remainder 5 and 7 respectively. That's a good question again. You have to find the biggest number of its kind which will divide these two numbers by leaving remainder 5. I mean, you have to find that number which, if you use to divide these two numbers, the first number will leave remainder 5, second number will leave remainder 7. So idea is what? If you remove the remainder, left out part will be divisible exactly. So let us do that. If I subtract the remainder from 281, what is the remainder? 5. So how much I'll get? 276, 276. And 1249, if I remove the remainder, I'll be getting 1242. Now these two numbers are divisible by my required number. That means they are asking you, and they are asking you the greatest number. So what exactly you have to do? HCF of 276 and 1242. So for doing the HCF, let me just leave this for you. Of course, I'm not identifying which is the answer correct for you, but I leave this for you. You can do the HCF and you can identify here. So just background concept is that you have to find the HCF after subtracting the two remainders from the even numbers. Do it. Okay. LCM of three numbers you have to find. Let me find this because in my theory part I did not explain you. So you directly do the factorization. So it is 4 into 7. So 4 can be written as 2 square and then 7 to the power n. 44. 44 is 4 into 11. So it is this. And then 132. It is 12 into 11, right? 12 means 4 into 3. So 2 square into 3 to the power 1 to this. So what is LCM? LCM, you have to write all the factors. One factor is 2, another factor is 7, another factor is 3, another factor is 11. And then you have to write the highest numbers. For 2, it is 2 only. 7, it is 1. 3, it is 1. 11, it is 1. So let us try to make it easy. Can we do it orally? See, 11 multiplication is easier. So can you multiply this orally? Yes, easily we can multiply. This is 2 square. 2 square is 4. 4 is a 12. It is 84 into 11. Actually, from here, if you're wise, you can easily identify this is the answer. Why? Because if you even multiply 80 by 11, it will be 880. So the answer will be obviously more than that. Had there been two different answers, which is bigger than or closer to 900 something, then you would have done it, right? But still, you verify this, you will really get this answer only. 11 into 4, 44, then 88 plus 44, 924, right? So your answer is D. So sometimes, as I told you, it is wise to discard or rule out some of the options, then finding the correct options. If you know that these three are wrong, then fourth one will be correct, provided question is not wrong. Okay, if the product of two co-prime numbers is 53, co-prime. Co-prime means, this is a new word which I did not explain there, but in your class you know this. Co-prime means I can use one more word, relatively prime. Relatively prime means what? Those two numbers HCF is 1. Great. So answer is lying there only. Product of two co-prime number is 553. What is their HCF? See here, people means I'm telling you, students might try to factorize this, and they will lose all their times because they have already said this is co-prime number, product of two co-prime numbers. So co-prime number has HCF one. So immediately you get. Right. So here, what you need to know definitions. Okay. If the prime factorization of 2520 is this, then the value of a plus 2b. It's a very similar problem what we did, right? So I think there is nothing which I should tell you here. So this is also I leave for homework or self practice. Please do it. You can do one thing. You can pause the video for a little time and then immediately you can find the answer and keep doing this, right? Don't wait for the next moment to revise. Okay. Next. LCM of 24, 36, and 60 in terms of their prime factors. This is also very easily you can write, right? See, these questions are very, very straightforward, even if they are coming in the exam. I'm doing it, right? But I'm leaving those which are repetitive. LCM, yeah, this is a good question where students might do mistake. LCM of the smallest prime number. Smallest prime number is what? 2. Sometimes students get confused and they write 1 as the smallest prime number. But remember, 1 is neither a prime nor a composite number. So 2 is the smallest prime. Sometimes students write 3 also. The smallest odd composite. Oh my God. Sometimes you may be again confused here. Smallest composite is 4, but smallest odd composite is not 4. What is the smallest odd composite? Can you recall? 7 is not a, 4 is the composite, first composite number, 6 is the second composite number, but this is not odd. 7 is prime, 8 is even composite number, so that will not be also taken. So the smallest odd composite number is 9. So what is the LCM of this? Obviously there is no factor in common, so 18. So orally you can do it. See, in the reading time only you can finish this question. Next. Okay, A is equal to 2 to the power 7 into 3 to the power 10, and B is this. What is the HCF? This, so directly you can do it. HCF will take what? Lowest power in common, right? So 2 to the power 7 and 2 cube. So I should take 2 cube. First you check, is there any number 2 cube is there? If it is there, only one is there, then that is the answer. You need not really think about the other things. So time wastage is less. See, even if I'm speaking to you, this question took hardly 5 seconds to answer it. So you can save the time, right? Don't waste time in doing the calculations, right? Okay. Now next, LCM of the smallest odd prime number, that is 2. See, I was only committing mistake. It is not true. Odd prime number is 3 and the greatest two-digit number, that is 99. So what is the LCM? It is exactly dividing this, so LCM itself is 99. Some might have a tendency to write 297 by multiplying, but LCM is 99. Be clever. LCM of the smallest odd prime number. Oh, this question gets repeated. Sorry. Hmm. The exponent of 3 in the prime factorization of 243. See here, actually, you know this, right? But sometimes, because of not understanding the question, you may be not writing the answer. Actually, they are asking you what? You have to do the factorization of this and what is the power of 3 that you have to write. So 243, I think it is 3 to the power 5, right? 3 to the power 5, is it? Because 3 to the power 4 is 81. 81 into 3 is 243. So what is the power here? 5. So this is the answer. So if you know this oral computation of 243, it will also not take even 5 seconds, right? Okay. I'll be telling why still I am knowing this. These questions are easy. Why I'm taking in the revision. I'll tell you at last. Okay, LCM of these numbers. LCM of these numbers, right? So here too you have to do. There is no way out, right? So 850 is equal to what? Do the LCM because these are MCQs. You need not really do these divisions. It will take time. Try to do many parts orally. I can write this as what? 85 into 10. So 10 means 2 into 5. 85 means what? 17 into, no, not 17 into 5. How 17 into 17 into 5? 19 into, 17 into 5. Yes, yes, yes. Sorry. 35. Yes, yes. 17 into 5. So here factorization is what? 2 into 5 square into 17 to the power 1, right? So now 500, 500, how can you do? 100 into 5. 100 matlab 2 square into 5 square, and then there is another 5. So 5 cube. So now what is the LCM? LCM means all factors with the highest power. So 2 highest power is 2, 5 highest power is 2, not 2, 3, and then 17 is this. So your answer is 17, 5 cube. Yes, so you may be having a tendency to do this. It will not be. Then this is also not the answer. So I can say 17. Will 17 give you this? Yes. 17 into this. This is going to give you 100, right? Sorry, 500. So your this one is the LCM, right? So be very alert. They're giving you the questions which is deceptive. You may be having a tendency in hurried manner to see that fourth one correct. Okay. Okay. 1080 is written like this: x minus y. So I think I can leave it for you. It is an easy problem again. Prime factorization, again the same thing. So I leave this for you. Again, I am leaving it for you, right? Okay, now the trend is changed. We are going to get assertion region problems. I think only one or two we got in 2024. Very less number of assertion region problems are there. So you all can remember what are the conditions, but still I wouldn't. I would like to remind you. A is the option where both assertion and regions are correct, and region is correct explanation of the assertion. Whereas B is showing you both the statement correct, but it's not the correct explanation. R is not the correct explanation. And C is stating you A is true, but region is false. And D is region is false. Sorry, assertion is false, but region is true. This is set in 2024. So what they have said, just you mark this here itself, you'll be doing 2 plus 2 is an irrational number. Yes, true. Why? Root 2 is irrational. So you are adding with a rational number. So it will be irrational. Okay, fine. The sum of a non-zero rational number and an irrational number is always irrational. Is it true? Yes, it is true. It is true. And this is what we did here. 2 is a non-zero rational number. So it's a correct explanation. So I can write. But here I would like to add, it's not only non-zero. If any rational number you add, even zero also if you add to irrational number, result will be irrational only. I just explain you additionally. Oh, only one assertion region was there. Now we are going to get into the descriptive problem. So it will take little more time again. So please, if you want, you can go for taking a little rest for 5 minutes. You can go and drink water and come back and we'll do the problem, right? So let's start. These are descriptive problems which will be very trivial. I'll not complete that. I'll just start it, initiate it, calculations you have to do. In a school, there are two sections of class 10. Okay. There are 40 students in the first section and 48 students in the second section. Determine the minimum number of books required for their class library so that they can be distributed equally among both the sections. What do you think? They can be equally distributed. That means you have to distribute the book equally to each and every student. So obviously book total number will be such that it is divisible by both 40 as well as 48. So you have to find the LCM, right? That number of books. So what I can write? So I'll just write here as the proper state of solution. So you write here number of children in section 1. There is no mention about section A or B. So section 1 first section is equal to how much? 40. Number of children in section 2 is 48. To find the required number of books, we must find LCM of 40 and 48. Now you can find the LCM. So how you can find LCM? Now 40 equal to 4 into 10. So, or you can write 8 into 5. So 8 means 2 cube, 5 to the power 1. 48, 16 into 3, that is 2 to the power 4 into 3 to the power 1. So what is the LCM? LCM means you have to take the highest power of the factors. So 2 power 4 you will take, and then 3 to the power 1, and then 5 to the power 1. So this is 16, 16 5s are 80, 80 into 3, 240. So please give the last conclusion. Therefore, 240 number of books are needed. So whatever books you bring, 240 numbers you bring, and that you can equally distribute. So that's the answers, right? Okay, good question. Next, 5 minus 2 root 3 is an irrational number, right? You have to show that it is given that root 3 is irrational. I'm doing it in two ways. Whatever way you like that you do. I'm doing first with the way which usually you apply. How do you do? You write like this. I'll write minimum statement. Huh? You know the statement. So you write if possible. I'm talking about the contradiction method. If possible, let 5 minus 2 root 3 be not irrational, sorry, rational. You consider like this. This be rational, right? Therefore, what you get 5 minus 2 root 3 is equal to a by b, right? Where HCF of AB is equal to 1 and AB where B is not 0 are integers. You write like this, right? It is very important. So from here, what you did, you try to keep aside what is root 3. So you entirely take A minus A by B to the right side, and then this is here. So now what you will do, this is 5B minus A. This 2 can be brought down here. And then you will simply say this is rational and this is irrational because root 3 is irrational given only. And here you say nicely that this is a contradiction. So this contradiction leads to say that this is irrational. Perfectly okay. There is no problem. Right? You can really do this. But thing is that you have an alternative as well. So you see, if you find it good, you can apply this also. How will do it? Right? So I write according to question, root 3 is irrational. I have root 3 irrational. Acha, if root 3 is irrational, what do you think? If I multiply this irrational number by one non-zero rational number, will it be irrational? Yes. Here you have to mention non-zero because if you multiply by zero, it will become rational. So here you have to write a statement as product of a non-zero rational with an irrational is irrational, right? Is irrational. This is R. Okay. Then after that, immediately, now try to see. We have already done one question, assertion reason. If you add one non-zero rational number with one irrational number, result is irrational. Similar is the case. If you subtract one irrational number from a non-zero rational number, even rational number will also do, then also this will be irrational. So here you write, I'm not writing that statement. What you will write as the difference of one rational and one irrational number is also irrational. Hence the proof. So that can be an alternative way of writing it. You check it which you like, right? Next, so that this number is composite. So now you try to see students what they do. Like they will start with this and they will completely break this number, multiply it. Don't waste time, my dear, because you are not supposed to complete this. You have to just say that it is a composite number. And what is composite number? Composite number are those which are having more than more than two factors. One except one and the number itself. More than that, if you get one also, you'll be okay. Fine. One means one factor I'm talking about. Prime number has only two factors, one and the number itself, and other number which are having more than two factors is called composite. So you have to just find a factor which is other than one and the number itself. So here you can see which can be taken common. Immediately you can take 11 common. So you'll be getting here 5 into 17 plus 3, right? So this shows 11 is a prime factor, right? Other than 1 and number itself. So what will conclude? Acha, how can you confirm that it is other than 1 and number itself? It's very clear it is not 1. And number is much more bigger than 11. So it has to be the proper prime factors, right? So you can write that 5 into 11 into 17 plus 3 into 11 is composite. That's it. So you can use this instead of multiplying all this. Don't multiply this. It will take unnecessary time, right? Okay. Oh, sir. Good morning, sir. Asu, asu. হা নাই আছো দিয়ক আহিব নেকি আজি হ'ব দিয়ক ছাৰ হ'ব ছাৰ অ'কে okay. So let us go for the next. In teachers workshop, in a teachers workshop, the number of teachers teaching French, Hindi, and English are 48, 80, and 144 respectively. Okay. Find the minimum number of rooms required in each room. If in each room, same number of teachers are seated and all of them are from the same subject. Have you understood the question? You have, I'm doing little rough work here. It is very clear. You have to find the HCF of all these numbers. So that part you can do. I'll explain the problem. You have friends, there are 48 number of teachers. Hindi, you have 80 number of teachers. And English, you have 144 number of teachers. Now you have to make them sit in rooms, right? Suppose these are the rooms. But the condition is that you have capacity of equal seats in each room. Number one. Number two, you cannot mix the subject. For example, suppose 40 number of French teacher you have kept in this first room and remaining 8 you mix with some others, not allowed. You have to divide equally all these subjects and you have to divide them in the rooms. So that means there must be a common number. There must be a common number which will divide all these numbers, right? And I need the biggest of that so that I can use the minimum number of rooms to accommodate them. Otherwise, I could have said that one room you give everyone, no problem. One subject, one room. One person, one room, one subject. Like this also, but this is abrupt. So here, what they are saying, you have to find the HCF. So I think statement you can write, but still, anyway, I'm writing this here. Always you write the given things. It is very important part, right? Given that number of friends teacher, right? It is 48. Number of, you can use comma, no problem. Hindi teacher, 80. And number of English teacher is 144. Right? So you just add one more statement. Now to find the required number of rooms, we have to find the HCF. So you find the HCF now, or you can do one thing. See, good idea. You do the factorization here only. You can get rid of writing statements, right? So 48 is 16 into 3. So it is 2 to the power 4 into 3 to the power 1. Then this will be 16 into 5. So 2 to the power 4 into 5. 144 is 12 square. 12 square. 12 is what? 3 into 4. Right? 12 is 3 into 4. So it is 3 square 2 to the power. Hmm. No. 12 square. Yes. 12 square. How will I write? 16 into 9. Yes. 16 into 9. So 16 into 9 means 2 to the power 4. That's right. You can remember if orally, it will be very good. You need not do the rough work. So you've got this. Therefore, or now HCF, because already you have written the statement. So HCF of this will be how much? You have to take the common factors, right? Only the common factors. Remember it for HCF. And you have to take the lowest power. So 2 it is power 4, 2 it is power 4, 2 it is power. That's great. 16. Right? So every room size or capacity should be 16. And you can see by 16 you can divide all these numbers equally. So every room you put 16 teachers. Then in that case, one more additional part may be given. It is not given here because it is a 2 marks question, I think. They might ask you how many rooms are needed for the friends. So how many will be needed? So you have to divide this by HCF. So 3 rooms will be needed. For Hindi teachers, it is 5 rooms. For English teachers, it is 9 rooms. They might ask you this also. How many total rooms are needed? So you have to add this up. So that can be a question for you. Be very alert. That can be added part. Good. Now next. Can the number 15 to the power n being natural number, and with it is 0? Give reasons. So let me answer it because I know you are knowing it, but just I want to answer it for showing you the statement what you will write. Right? So you write here Uh, we have, you first do the factorization of the number. 15 is equal to what? 3 into 5. Therefore, 15 to the power n will be what? 3 to the power n into 5 to the power n. Acha, what does this show? It shows that 15 to the power n has only two prime factors. One is 3, another is 5. And prime factorization guarantees us that 15 to the power n cannot have now any other factors. No other factors are possible. No other prime factors. Only 3 and 5. Fine. Then you write. Also, also we know that, also we know that, also we know that a number ending with 0 is divisible by 10 and so by 2 and 5. That is, it must means I'm talking about the number. It must contain both 2 and 5 as prime factors, as prime factors, so that, so that it ends with a 0. Right? Now just justify. Do you have both the factors here? No, 5 is there, but 2 is not there. So you can directly write. Therefore, as 15 to the power n does not have 2 as prime factors, prime factor, 15 to the power n can never end with a 0 for any value of n. That's it. That's a good question. You have many questions here. I can write 6 to the power n, I can write 8 to the power n, anything, right? These are all equivalent questions. It's a 2 mark question. So for showing the statement, I have written this. There is no other um, motive. Prove that root 5 is irrational number. I know that you all know it, but still I'll write the statement for you. Here also reason is very clear. I want to show you what perfect statement you can write. I know that you all know it, but still I'm writing it, right? We'll go for the contradiction method. Here I cannot say that we know that root 5 is irrational because this itself is a problem, right? So I'll write if possible let root over 5 be rational, right? Therefore, root over 5 will be equal to this, where HCF of A and B is equal to 1, A and B, where B is not equal to 0, are integers. So after this, immediately what you will do is square it, right? I'll take a step short. You can also do it. I'll do the squaring and at the same time I'll multiply this, cross multiply this. So I can get a square equal to 5b square. A square equal to 5b square. What I did, squaring and then cross multiply. Now from here I can say that 5 is a prime factor, right? Mm, okay, prime factor of 5b square. That itself will tell you that 5 is a prime factor of 5b square means a square. Now you can bring that theorem. So 5 is a prime factor of A as well. So what is the statement you should write? Since P divides A square implies P divides A, P being prime, right? Many students do not write this. Please write it. It is a very important thing because if your marks will go beyond 75 out of 80, we'll deduct mark for this. So if 5 is a prime factor of A, I can write very well 5 equals A equals 5 times M. And what is M? M is some integer. M is an integer. I'm not bothering what integer, but M is an integer. Good. So once you get this, you have to use this equation to put this value of A. So you put in equation 1. So you will be getting what? A square, that is 25 M square is equal to 5B square. So that gives you 5 M square is equal to B square. So now here again, I'll not write it here. I'll not remove what I have written. I am writing in this free space, right? You will understand that because already you have revised it. So here in this particular state, after that, what will be the implications? Again, it is same that 5 is a prime factor of 5 m square. So if it is a prime factor of 5m square, 5m square means what? It is b square, and that means 5 is a factor of uh, b. Why b? Because I have this theorem. Now again you will state the theorem here. This theorem only. So now it is very important. This is showing 5 is a factor of b, and this is showing 5 is a factor of a. So conclusion is what? Therefore, 5 is a common prime factor, right? Common 5 factor or prime factor of A and B. My handwriting is little less smaller. Try to adjust it. What is this? So directly you can say that therefore HCF of A and B cannot be equal to 1. And this is a contradiction. Why is this contradiction coming? Because of a wrong supposition. So you can write, you write which is a contradiction, which is a contradiction, and this contradiction leads us to conclude that root 5 is irrational. Right? Please write this kind of statement. I'm sure that you already have understood, but still, for your convenience, once more I did, even if it is a very common problem, very usual problem. Okay. Now you see, this I need not do because already we have done 15 to the power n. So there we got uh, 3 and 5 as the factor. Here it is 8 to the power n. So you get only 2 as a prime factor. 5 is not there, so it can never end. So you try to write this statement yourself. Don't postpone this, right? You pause the video now only, you do it, and then you go for the next. Okay, this is a good question. This is a very good question because people sometimes do not understand this. It is a very good question, and there can be varieties of this. Three bells toll at interval of 9, 12, and 15 minutes. What does it mean? There are three bells which rings, tolls means rings, which rings after 9 minutes, after every 9 minutes. That means if it is now ringing, after 9 minutes it will ring, then after 9 minutes again. then second will be after every 12, then third will be after every 15 minutes. If they are tolling together, after what time will they next toll together? What do you think? It's a problem of LCM. Why? Because you should get such a common timing, which is actually divisible by 9, 12, and 15. So what does that indicate? You need to find the LCM. So my dear students, I just want to tell you, whenever you are dealing with this kind of problems, don't just read the question and try start doing this. You first try to compare with the situations, try to understand it. I'm sure you will never do any mistakes here. These are very easy. So here we need to find the LCM. So you will write a statement, but first you write now 9 equal to, it is 3 square. Sorry, this multiplication is not there. 3 square. 9 is 3 square only. And then 12, 12 is equal to 2 square into 3. And 15 is equal to 3 into 5. Therefore, in the meantime, you will write a statement why LCM is needed, right? So you must write what I have told, that as they will again ring after that time, which is common divisor of, common multiple of 9, 12, and 15, we need to find the LCM. So you write like this. So for LCM, you need all the factors with the highest powers. So 2, what is the highest power? It is 2. 3, what is the highest power? 1, 5, 1. So it is 4 3s are 12, 12 5s are 60. So after 60 minutes, they will again ring. That means if now it is ringing, after 60 minutes, again they will ring together, all the three. After 60 minutes means 1 hour. Now you see what creativity we can do here. Instead of asking you after what time they will ring together, we can fix a time. Say at 9 a.m., all they are ringing together. So at what time next they will ring together, right? So you have seen 60 minutes, that means 1 hour. At 10, they will link together. 10 a.m. Very good. Another implications, another question which we can be deriving from here. I can ask you, there is a mistake. Oh, 9. Oh, sorry, dear students. I consider this as 2. So I have put, it is not 2. 2 will be there. I'm very sorry. It is 180 minutes. I'm very, very sorry. I take my words back. It is 180 minutes. That's what. 180 minutes. 180 minutes means 3 hours. So if it is 9 a.m., then 10, 1 hour, 11, and then 12. If it is a.m., then it is 12 noon, right? So 3 hours it takes so that it will ring again together. So, and then I can ask you this question as well, that how many times does the first bell ring in between this span, right? How many times, right? So you find it. The total duration is how much? 1 hour, 3 hours, 180 minutes. So 9 will divide this in how many times? It is 20 times. So can you say that in this duration, the first clock or first bell rings for 20 times? It's not 20 times, it is 21 times because you are including 9 a.m. as well. So be very alert about that. Okay. Now, this is same question, right? We did, but this time it is for division. So I'll just write the outlook here. Outline, not outlook, outline here. Statement you will add. How we'll start with? I'll go for the alternative one. Root 3 is irrational, right? I'm just writing it like this. It is not a formal statement because already I have shown you one. I'm not writing it. Root 3 is irrational. Then immediately in the next step, you can write. Okay, let me write in the next step only. Then you can follow the steps and you can complete the problem. 2 minus root 3 is irrational. And why it is? You can say that difference of one non-zero rational, even you can write simply rational, it will do. Rational and one irrational number is irrational. Then next step, what you'll do? Division of one non-zero rational and an irrational is always irrational. So that way in the three steps only you can complete the problem. So please adapt the statement and complete the problem. Okay, this is a very good question. How will you do it? See, don't go for contradiction here immediately with this. Don't consider that this is irrational. Don't do it because they have already told you that this is irrational, right? So first, now you start with the expansion of this. You break this. If you break it, a square, matlab root 2 square will give you 2. This is 3. And then this is 2 root 6. And then 5 plus 2 root 6. So now here what you can write? Non-zero. No need to write non-zero actually. You write here because 0, if it is rational, 0 will also do. So you write simply rational plus irrational. Why irrational? Because root 6 is irrational, already it is given. You give a statement here as 2 root 6 is irrational, right? And if you're not satisfied, you can still say 2 root 6 why it is irrational. So this is going to give you irrational, right? So you can prove it like this. I'm writing only irrational. Please write completely rational number, irrational number like this. That's it. Okay. Go for the next. We are coming to the end of the class. So hardly, I think, 10 minutes. So this is a question on the factor tree. I have found only one such question here in 2024. But this is a good question. Please try to do it. Students may be having doubt here also. Okay, find the values of x, y, z and w in the following factor tree. Also write the prime factorization of x. So you all know, I just want to discuss here. They say if it is 12, whenever we do the factor tree, we write one factor here and the another factor here. Say it is 3, then it will be 4. What does it mean? These two, if I multiply, I get back the other number. So this can be the idea which you can use, right? So here you can see here, last you go backward, right? Start from that. 17 into 3, right? 17 into 3 will give me W. What is the W? W is in 91. 17 3s are 91, right? 17 3s are 91. So you got W equal to 19. So you got this as 91. The next Z, if you want to find 3 into 91. What is 3 into 91? 27. It is 273. So you got Z equal to 273. Then you, now Z you got, this also you got. Now, both these numbers are obtained. Both these numbers are obtained. So you need Y. How will you get Y? 8, 19 will be multiplied by 2. So what will be Y? 1638, right? And at last 1638 into 2 will give you X. So you get the number. See, it is not a difficult one. So 2 times 32, it is 76, 3276. So you get this. It is one of the part. But sometimes filling up this, after filling up this, students forget that they are to answer something else also. What is the answer? Also write the prime factorization of x. That means x is equal to what? So x, what are the prime factors? Can you see? You need not really go right side. You come down here up to this. And it is very clear. It is 2 into 2 into 3 into 3 into, you can write 7 first. This is the prime factorization. And what is the number? Is 3276. That's it. Okay, that's an easy question. It was, I think, getting 3 marks. Okay, now you see, this is like that veil one. So I don't want to do it completely. I'll explain it. You will do it as a practice work, but do it now only. Pause the video and do it. Two alarm clocks rings their alarms in an interval of 20 minutes and 25 minutes. Earlier we did for three, here it is two. The first beep, they first beep together at 12 noon. At what time? Yes, what I was talking about, this is happening here. Beep again after the next time. So what you will do? You will find the LCM of this. So LCM orally you can see, right? I think it is 100. No? LCM will be 100. So after 100 minutes, they will again ring together. 5 square and then 5 will go there. Yes, 100. That's 50 is not divisible by 20. So after 100 minutes, they will ring together. 100 minutes means 1 hour, 40 minutes. That means at 1:40 p.m., 1:40 p.m., they will ring together. Okay. So you can easily write, you have to find the LCM. Okay. Find the greatest number which divides 65 and 117 completely. Greatest number which is dividing them. It's not that the greatest number will be divisible by these two, right? Because there will be infinite number of greatest numbers. I mean, numbers. There will be no fixed greatest number, right? So here they are asking you to find the greatest number which divides 65 and 175. So what do you think? It's a common factor, right? Greatest of the common factors. So they are to find HCF of 65 and 117. Please do it. Pause the video, do it and check what is the answer, right? Okay. Oh, LCM of this by prime factorization method. I just included this question to show you that these kind of easy questions are also there in the board. I leave it for you because you know this, right? And we have done a lot of such problems with this particular rule, that if two numbers are there, HCF is known, LCM, how can you find? It is the question. Directly you can use product of two numbers is equal to product of the HCF and LCM. Okay, this is a case study problem. Probably this is the last question. This is a case study problem. I found one of them. Teaching mathematics through activities is a powerful approach that enhances students' understanding and engagement. Keeping this in mind, Mrs. Mukta planned a prime number game for class 5 students. She announces that the number 2 in her class, announces the number 2 in her class, and asked the first student to multiply it by prime number. Multiply it by prime number, another prime number. Then pass it to the second student. Second student also multiplied by prime number and pass it to the third student. In this way, by multiplying to prime number, the last number is this. Have you understood the process? Suppose I am giving you a number 2. You have to multiply this by any other prime number. Any other means you can multiply by 2 also. It's not told that you cannot multiply by 2. And then whatever result you get, you pass it to the next friend. She or he will again multiply by a prime. And then the process is continued for the whole class. And they have ended up with 173250. Now, Mukta asks some questions as given below. What is the least prime number used by the student? Be careful. The least prime number used in this is 2. But it is not saying that that is the least prime number used by the students. So you have to do the prime factorization. So this is a problem of prime factorization. So let me do this as it is the last problem. So you first do the prime factorization, right? By 2 I can divide. It is 8, then 6, 6, 25. So obviously from here in the first step only you can identify that 2 is not the prime number used by the student, right? Because 2 is coming only once and that is used by madam. So, okay, last is 5. So I can be sure that it is divisible by 5. But because I need the least, you can test it also first. Is it divisible by 3? How can you check the divisibility by 3? You add up all the digits. That result you try to divide by 3. If it is divisible, 3 will be a factor. So let us try it. So 8 plus 12, 20, 27. 27 is divisible by 3. So this number will be divisible by 3. So you do this because you have to show the prime factors. So I do it 2 times. 26 if I do 8 3s are 24. Again 8 3s are 24, 22, 7 3s are 21, 15, it is 5. Right? So here you'll do it, but I'm writing the answer. 3 is the lowest prime number used by the mm, students. There may be again repetition. Hmm. Repetition will be definitely there because the sum was 27. 27 is divisible also by 9. So this number will be divisible by 9. So you can divide it by 3. So 7 3s are 8 3s are 24. 9, yeah. 9 3s are 27. 18 it will be 6 and then 25. Now is this divisible again by 3? Let us see. 15, 20, 22. No. Now it will be divisible by 5. So 5, 46, 2, and then 5. Again, it will be divisible by 5. 5 3s are 15, 42, 5. Again, it will be divisible by 5, 35. Then it will be divisible by 7. Right? So now let us go. How many students are there in the class? How many students are there in the class? So you see by how much time you have multiplied. So you can see 1, 2, 3, 4, 5, 6, 7. Multiplication is done for 7 times. So how many students are there? 7 students. What is the highest prime number used by the students? Yes, we can see it is 11. Which prime number has been used maximum number of times? Yes, 5 is the prime which is used for maximum number of times. That's a very good question, right? But you see, if you don't think it justified in the exam, you may find difficulty in doing so. This is a good question. This was the last question of mine. So thank you so much. And here, here I'd like to tell you one thing. Real number has been finished. With this, I think you will prepare well. You go through NCERT each and every problem. Go for simple papers. In one video, I'll show you how to solve the simple papers. So all the best for the board exams. And for any kind of queries, doubt, you can really comment on the video. Thank you so much and bye bye, dear friends.